Hi everyone, I saw in YouTube quite interesting device, dynamic backlight for monitor. It is assembled on Arduino and I really wanted to repeat this design. But before assembling it was necessary first to order an addressable RGB tape. When ordering we can choose the color of the tape, white or black. And since my monitor is black, I chose this color. Length 1, 3 or 5 meters. Also pay attention to the number of LEDs per meter. 60, 30 or another number. The difference in price between 30 and 60 is not significant and I still advise you to overpay because the detail will be much better, but also do not get carried away. 60 LEDs per meter, the best option for our task. And one more thing, protection class IP30 and IP67. The first, just a tape, the second in a silicone shell. In silicone seems to be more evenly disperses the light, but for myself I chose a simple tape without protection and also a power supply for 5 volts. At the same seller can choose power supplies for different voltage and current. I ordered for 5A, but as practice has shown, for a 20-inch monitor, because in the brightest mode tape consumes about 2 amperes. And here the parcel was received, a reel with 3 meters of tape. Connection is very simple, plus, minus, and one more contact on which the data will be transmitted. There is no controller in the kit, but it is not necessary. We control everything through the Arduino, a plug and 2 wires for connecting an additional power supply. Now you need to measure out the sections of tape that will be glued up and down and along the sides of the monitor. The number of LEDs here and here should be equal. And since my monitor has a curved cover, respectively, in the upper part of the length will be a little more. So we will measure from the bottom of the case. And we see that in the upper part of the tape actually turns out as if shorter by 1 centimeter. It's nothing to worry about. We take scissors and cut it off. Similarly with the side pieces, measure, cut. There is still a lot of LED tape left, so there will be some more interesting self-design. In the end, you should get something similar to this design, with the beginning in the lower left corner and then counterclockwise. I connected the ribbon fragments using the leads of radio parts and a piece of wire. And attention, here I made a fatal mistake, as a result of which I spent about an hour looking for the reason why I have nothing glowing. As you can see when unwinding the tape, both sides of the tape had soldered wires for connection. And that would be alright. But there is a huge difference in which side to apply the control signal from. The signal direction is also indicated on the tape, but I didn't pay attention to these arrows at all. I had to redo everything, so be careful. Now we take our semi-finished product and carefully glue it to the monitor. It remains to connect the Arduino Nano board. I will also leave the link in the description, but it is not connected to the tape directly, but through a 200-500 ohm resistor. Control is connected to pin 13 of the Arduino or another if it is configured in the sketch, and also need to connect the minus pin of the Arduino with the minus power supply. I fixed the board with hot glue and now I need to calculate the number of LEDs along the entire length of the tape. Horizontally, I got 28 of them, vertically 16, that is the total number of 88 LEDs, and proceed to the firmware and customization of the software. Download the archive with everything you need from the link in the description of this video. In the archive, find a folder with an obscure name and copy its contents into the folder with libraries Arduino. Then, copy the Guyver ambilight folder to the place where you store your Arduino precuts. By default, it is the folder My Documents Arduino. Start the Arduino IDE, select the port to which you have the Arduino board connected, and select the Arduino Nano board or the one you are using. Next, open the Guyver ambilight sketch, enter the total number of LEDs in the strip. I have 88 of them, as you remember. The pin that the control input is connected to You can use any digital port on the Arduino. And you can also play with other settings such as minimum and maximum brightness, color check, and more. Pour in the sketch and in a few seconds the Arduino is ready to go. The final step is to install the AmbiBox program, which will actually transmit data from the computer. Go to the program settings, where we choose the language, whether to start the AmbiBox together with system booting, whether or not to show the tray icon. In general, various nonsense. Let's move on to more interesting settings. In the device field, you need to select Addlight. After clicking on the More Settings button, it gets even more interesting. We choose the order of colors in the ribbon. Usually nothing needs to be changed here. Port to which the Arduino board is connected, and specify the number of zones, that is the number of LEDs. I have 88 of them. And the method of screen capture, I work only GDI, and the difference between Aero and not Aero in general did not notice. Now we click Show Capture Zones and Zone Setup Wizard. Since there are no corner LEDs, we uncheck the corresponding checkbox and enter the number of LEDs horizontally. I have 28 and vertically 16. However, we see that the number of zones horizontally does not match. And if you set 30 LEDs, everything is okay. We leave it that way. And at will we can expand the capture zones. During viewing, I noticed two shortcomings. First, there is some delay between the transitions on the monitor and on the tape, and it does not depend on whether the arrow slill is selected or not. And the second drawback, there is no clear white color, white bluish tint. That's why we go to Advanced Zone Settings. Here I tweaked the color correction a bit, took out the green and added red. Now white looks like white, and I also played with the gamma level of the correction. As a result, the colors on the monitor and on the projection completely match. And in order not to have any lag, I turned the anti-aliasing to 0. By default, it is slightly on. It makes the transitions smoother, but the delay is very noticeable. If you set it to 0, the transitions become sharp and the lag disappears. In general, adjust to your preferences. Save the settings and enjoy the result. Let's see how the ribbon flashes. It seems to be nothing special, some kind of color music on LEDs. Now turn the monitor with the ribbon to the wall and get the wow effect. In fact, appears even some effective presence while watching movies. It feels like the action takes place somewhere inside the monitor, and behind you can see how the shadows move. There is some movement. After a couple of days of using the new monitor, decided to turn off the backlight, and as they say, not that coat. In general, the thing is really great. I advise everyone. And now, how the anti-aliasing adjustment affects the speed of the background backlight. Thanks for watching. Thanks to Alex. All links to the ribbon, power supply and Arduino in the description below the video.